All right, we are now on to day 4 of review, and we are going to be covering factoring. Factoring is awesome. It's easy. It always works out if you know what you're doing. Let's start with example 1 and go from there. So this is a review. What's one of the first things I should do here?
You should converge. Oh, take out the x's.
I can take out, they all have an x that I can factor out. Anything else?
You could take out a 2.
I can take, yes, thank you, thank you, thank you. I can factor out a 2x. Now, some of you might be thinking, well, eventually when I slip and slide, you should not slip and slide until it's completely factored anyways. If I take out an x here, and I get x times 2x squared plus 4x minus 6, I can't slip and slide that if I can still factor out a number, and I can't. You guys told me I could take out a 2x. So I've got 2x, x squared plus 2x minus 3. At this point, my 2x comes along for the ride. Okay, this is done. It's factored out. I need to factor this. And what do I do with them?
X plus 3 and x minus 1.
I like this. I cannot lie. Okay, so booty cheek time. It is booty cheek time. Booty cheek time. That's why I call it booty cheeks. All right, and we have our axes, and you guys are good at this. You need to find two numbers that multiply to be -3, that add to be 2, and they are
3 and -1.
+3 and -1. Good, 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 good. Not crazy. Nothing new. Same too chatty. All right. Yeah, we're not solving. If I was solving for x, I would have to take each one of these terms and set them equal to 0, wouldn't I?
Yeah.
But I'm not solving, I'm simply factoring. That's why when it comes to solving, people are like, oh, it's so hard. I'm like, well, if you know what a factor is, it's easy.
Don't you just got to do opposite?
Yeah. For the cheeks, yes.
Okay, what you do for the 2a?
You just set that equal to 2. It's not opposite, it would be 0.
Oh.
All right? So, let us move on. Yeah, that's all. Perfect squares. When I have two terms that are perfect squares and there is a minus between them, what can I do?
Yeah.
How you doing, Wes? Oh, that's cheating. That's the solve. If you talk about add 9 to both sides, is that what you're saying? Or are you saying to add 9 to both sides, take the square root of both sides?
That's what I was saying.
Okay, if that was equal to 0, yes, but there's no other side to bring the 9 to here, so just fact. One cheek or two cheeks?
2 cheeks. Oh, +y and -y. No, +3 and -3.
Thank you. Look it. These are perfect squares. Two ways that you can consider this. If there's a minus between them, okay, these last two terms have to be negative. So one needs to be positive and one needs to be negative. If they were both positive, when I multiply them, this would not be negative, it would be positive. Same thing, if they were both negative, when I multiply them, would still be a plus there. All right? Another way you can do it is if they're both perfect squares, the square root of x squared is x. The square root of 9 is 3. Oh my God, look at that. One's a plus, one's a minus. How come one's plus and minus? It cancels out the middle term. There's no middle term there, is there? That is x squared. It's not plus 6x minus 9. It's x squared minus 9. There's no middle term. You need a plus and a minus to cancel out the middle term. Another way you can do this, and you don't need to know every way to do it. You just take the way that's easiest for you. You can actually put your 0 x's in here. I have no x's.
Oh,
Yes, now I can do the product sum. What are two numbers that multiply to be 9 that add to nothing? +3 and -3. You can do that as well. Okay. So, with that being said, how would I factor example 3?
You can take out a 5. No, you can't.
You.
It's perfect squares.
They are perfect squares. They are perfect squares. What can I do if they're perfect squares? Like this one's a perfect square.
You can just, you can factor that. Oh, not that.
can take the square root of both of them, right? Look at, what's the square root of 25x squared?
5x.
5x. What's the square root of 49? Guess what? There's a minus there, right? There's no middle term, is there? One should be a plus, one should be a minus. 5x and 7. There you go. Yeah, you're welcome, children. You're welcome. How we doing? We feeling good? It is Friday. It's Friday and... Stop it. You know you love that. In fact, we're going to do this so the next time it plays. That's okay. All right. All right. All right. Now, how do we factor this? I can technically do slip and slide here, which is what a lot of you might do. There. All right? So, those are both perfect squares. But when I say both, the front and the back are perfect squares. So we can do something here. We can try something and see if it works. What's the square root of 9x squared? 3x. What's the square root of 1?
1.
Okay, now, here's the catch. Is there a middle term?
Yes.
Yeah, so I can't do plus and minus. That would cancel out a middle term. What sign is in the middle? Guess what? What? That's the same thing as saying 3x plus 1 times 3x plus 1. There's a way I can check to see if that works. You ready for this, children? No, calculator, stop it. Okay, we said the square root of 9x squared was 3x, right? We said the square root of 1 is 1. If I multiply them together and then double it, it should add to my middle term. 3x times 1 is 3x. Like I would have 6x. So no worse. A lot of you would do slip and slide here. You multiply the back times 9, then booty cheek it, and then divide both by 9. And that would work as well. We'll get to the slip and slide situation in a minute. Okay? So you can take a look. Yep. You can take a look. If they're perfect squares, all right, but there is a middle term, you can't have plus and minus. It's either going to be 2 pluses or 2 minuses. Guess which sign you put there? Whatever sign is here. That's what goes there. So you walk me through the next one. Do we have a perfect square in the front and back?
Yes.
Okay, what's the square root of 4x squared? 2x. What's the square root of 9y squared? Okay, is there a middle term? Yes, there's no... If there's a middle term, I can't put plus or minus. So what sign do you think goes in the middle? Whatever sign's in the middle here goes here. Yeah, and I can square it. Or I can just say 2x minus 3y times 2x minus 3y. But why would you write that twice when you don't have to? This is pre-calculus. This is the same as 2x minus 3y times 2x minus 3y.
Why used to write it? We did that? No. Well, we did.
You did learn it last year. I taught it to you last year. It was at the beginning of last year. You're like, this is so simple. How come you didn't teach it to us? I did. It's so simple. You didn't bother to remember it because I said you saved your brain from the difficult stuff. But this really, it helped you look back. In one ear, out the other.
That's how I go every year.
You're sitting here in this class, you're like, I got it. And then you walk out that door into the hallway, you just forget everything you just put. Okay. I want to show you something. Most of you should remember the slip and slide method. And I will prove to you that I taught you this last year because I used this. Is this the audio? What's the audio? Oh. No, wait for it.
That's enough.
Before we do that.
I'm certain I prefer Netflix. But until I'm in like.
I prefer white food.
That's racist, the black and the white guy.
No, we're different kind of.
Okay, everybody, come outside. Everybody ready for a wild wet ride?
I swear to God, that's an actual commercial from like the 80s. That is the audio
I remember that.
of an actual commercial from the 80s. They sell this thing. Yeah, he's floating. They used to sell this thing, and you would put it in the front yard, and you try to see the water goes. And you know what happens on a slip, and you run and slide down and stuff. And one kid in the neighborhood used to have these things. Just one, not every kid. One kid had it. And you would walk outside, and you see it all set up, and you go back inside, and you put on your swim trunks, but you had them on the whole time with your shirt and walk out. What you guys doing? You guys are slipping slide? Okay, you sticking shit up. Like, I'm not going back. And everybody used the one foot slide in the neighborhood. It was so fun. But I wanted to show you the actual commercial. Right. Okay? Here we go. Okay, everybody, come outside. Everybody. And the father that owned it probably looked like that guy who had it set up.
It wasn't that far. They really had one like that.
You slide on your tongue. Let me explain to you the way that used to be set up. Every once in a while, you have someone that owned it that would have a fence around their yard, and they would do the simple slide so it would end like a foot in front of the fence. So your bigger friends would run down there, and they couldn't be stopped at the end. You just go right to that metal fence. It was great. Good stuff. Good stuff. Anyways, let's apply slip and slide to factoring. Okay? Let's apply slip and slide to factoring. Now, who remembers how we use slip and slide? First of all, can I factor anything out of this example 6? Can I factor out an X or a number? Oh. No, you can't. So this is what we do. We slip the 35 out back. Okay? That's the slip. That's the slip. And now I have x squared minus x minus, what is 35 times 12, those of you with a calculator? 420. Now I booty cheat this, because you guys are comfortable with a factor sum thing, where we find two numbers that multiply to the back term that add to the middle term, okay? Now, who here, I already have it in my head, because I remember this from last year. Okay, what are two numbers that multiply to be negative 420 and add to negative 1? Now, keep in mind, my product is negative, isn't it? So I got to do a positive times a negative. Should the positive or negative number be bigger? The negative number, because they should add to negative 1. In fact, the negative number should only be 1 bigger. So it should be like positive 18, negative 19. Positive 4, negative 5, if it's not. Stop it. End with a 0. One of your numbers you multiply 20 times 21. So positive 20 times positive 21. They multiply to negative 420, and they add to negative 1. We're good. So we slip. Where does the slide come back into play? I slide the same number that I slipped out. Sorry, I don't know what the hell just happened. I slide the 35 back in as fractions. That is the slide. And all I need to do is I reduce those fractions and then bottoms up. Can these be reduced? Can 20 over 35 be reduced?
Yeah, 4 over 7.
X plus 4 over 7. And what can 21 over 35? 3 over 5. The 7 wasn't the 21 times. 5 times. Now the last step is bottoms up. Bottom pops up. Bottom pops up. So when I factor that, it is 7x plus 4 times 5x minus 3.
This one is behind.
Slip, factor, slide. Oh my goodness. Record. right, example 7. This should look familiar because that's example 5. It's the same thing. That should end up being 2x minus 3y times 2x minus 3y. Only this time, I want you guys to slip and slide.
So we got to take out the board.
So, yeah, you guys, you tell me. Someone said slip the 4 out back, and that is correct.
Slip the 4 out back.
You good?
Multiply 9 times 4.
So we got x squared minus 12xy plus 36y squared. Now, I'm going to say something to you. A lot of you guys freak out. There's the y squared in the back. There's the y squared in the back. Look it. If there's an x squared in the front, don't we automatically go, oh, that means it's an x and an x?
Yeah.
If there's a y squared in the back, that means just go y and a y. Everything else works the same. Two numbers that multiply to be 36, that add to negative 12. 4 and 9 add to 13. 4 and 8 multiply to 32, but they do add to 12. 6 times 6 is 36. 6 plus 6 is positive 12. Negative 6, negative 6. When you multiply a negative times a negative, I get my positive 36. When I add a negative 6 to a negative 6, I get a negative 12. We are good. No. What's the last step here? Thank you. I'm going to slide my 4 back in and then reduce. Okay, that's x minus 3 over 2y. Okay, and I can say x minus 3 over 2y. Bottoms up, people. Oh my goodness. Oh my goodness. What do I end up with? 2x minus 3y times 2x minus 3y. I'm going to do something crazy. I'm going to compare this answer to the one we got previously when we did this, the perfect squares. Oh my God. Of course it was. It was a lot easier. So when you look at a problem like that, you're going to have to know, hey, maybe I can do this perfect squares. Even if you don't, you can still do it this way and get the right answer. There are more than one way. There is more than one way to get to one answer. All right? Bam! This is the last one. Oh, no, we have the cubics. And the cubics. Yeah. Here we go. Ready? Who can remember how we factor by grouping? This is the one that everybody forgets. You think you got it? Go ahead, Dave. Go ahead. Tell me what you think I should do.
Let's go here.
Really? Come up here. Wow. I like this. I like the confidence. That's amazing. That looks right. I don't know. We'll have to see. Go ahead. Yeah, it is called factor by grouping because we are going to group the first two terms together and group the second two terms together. Then I'm going to factor each one of those cheeks, if you will, independently. And what is outside of those two cheeks go together in their own unique set of cheeks. No, you know what? That's good. It's perfect. That is good. Let me explain. Perfect, Jaisha. If I can, you get one. I do have a little sweet tarts. Remember when I top right corner? And then give Javante the $20. Stop. All right, so let's go over this, shall we? Grouping. We group the first two and the second two. I'm going to individually factor them. Okay, I know an x squared can come out of here, so I will write it x squared times 3x plus 1. Right? I know a negative 2 can be factored out of here. So I'm going to write it as -2 times 3x plus 1. And the entire goal or purpose of doing this is I need these two that are left to match. Because look at it this way, children. I factored a -2 out of here, right? And I wrote it once. I factored an x squared out of here, but I only wrote it once, correct? Out of this whole mess, I am going to factor a 3x plus 1 out of it, but I only need to write it once. Yeah. So what I have left, my x squared minus 2 gets put here. So look at it this way. These two go on one cheek, and these two go on another cheek. You still have another 2 cheeks, which is normal. If one of you had one cheek, please don't share it with everyone. We will whip you for the rest of the school year. Okay. Nothing crazy? Nothing crazy? Okay, now it gets crazy. This is the one we hardly do, but we should practice it. We really should. All right. Last thing. 9 and 10. We're gonna factor perfect cubic binomials, which means they are cubes and they are 2 terms. That's what binomial means. 2 terms. Thank you for paying attention. I know this is all review. Let's get through it. We have this thing. If I have something where I have a minus between them, they are both perfect cubes, I can factor it as such, and I will explain in one moment what this means. All right? Now, really, I should write this as f cubed minus v cubed. If I have a situation like this, in fact, I would write it like that. Okay? I would write it like that. I take the cube root of each one of these. What's the cube root of x cubed? It's just x. Okay, so my first term is going to equal x. What's the cube root of 64? 4. 4. So my second term is the 4. I now have my f and v. Does anyone know why that is not f and s? Come on in, come on in, come on in. So, as I was saying, does anyone know why the first one we call f and the second one we don't call s, we call v? Because those are my initials, Frank Visca. My middle initial is s, so I was going to do f and s. I'm like, I should have done that. But you can use any initials you want. I just have to put myself in. Okay? And, my dad's an immigrant from Italy, and it's not Sam. And this is very Italian. I'll tell you after class. So now, this is what we're going to do. Okay? This is what we're going to do. Yes. Do you know how to do it? You want to come up here? Okay. What goes here? Yeah, now look at whatever my f is here. It's x. Whatever my v is, goes here. That's 4. We just came up with that. All you have to do is take the cube root of both and you just fill in the blanks. Okay? And there's a minus between them. Okay? What goes next? Well, whatever f is, I have to square it. F is my x variable, so I just square x. Plus f times v. What is 4 times x? 4x. Plus v squared. What's v? V is 4, but v squared is 16. You got it. And that's it. Now, the only difference between example 9 and example 10 are the signs. You see how example 10 we have a plus here, so the plus here and a minus here and a plus here. They're slightly different. I'm going to tell you if you ain't remember this, children. This sign here is always the same as the sign you start out with. See how it was a minus here? It's always the same. Always. This sign is always the opposite of what you start with. always. And this sign back here is always, yeah, I'll spell always correct, a plus. It's always a plus. You don't even have to worry about it. It's always a plus.
You do the next one by yourself.
Yes, you can. You're the next one by yourself. Don't say, tell them, hey, the next one by yourself anyway.
You did one right. Can I do it?
Maybe. Let me see. You make one move.
Oh, 9. It'll be 9.
No, that's a simplification. Are you going to go up here and do it? All right.
What is my boo-boo?
You will see, because I got a couple people who did this. All right? So we first, and as you do it, I will be explaining. The cubed root of 8x cubed is indeed 2x. The cubed root of 27 is 3. All right? So, 2x minus 3, remember. Wait, stop, listen. So, the first sign is going to be the same sign you're given, so it'll be a plus. The next sign is opposite of that plus, always, so it'll be a minus. And the last sign is always a plus. Thank you very much. So this is what we have here. And we don't even have to write this stuff here. This is, you can just write that and you are fine. Now, you were wrong by one thing. One thing. And a lot of people do this. The cube root of 8x cubed is 2x. So they see here, oh, I just got to square that, and they just do this. That is wrong because you need to square the entire thing, not just the x. You square the 2 and the x, so it's 4x squared. Okay? You are squaring the whole term, the variable and the number. And this is what you end up with. Very good. You guys are awesome. There's some homework.